welcome back. In this video I will be going over the main differences between electric vehicles and conventional vehicles, because once you get that, everything else sort of falls into place. I do a lot of outreach to mainstream media, and I found out most people don't understand the basics when it comes to comparing conventional cars with electric cars. In a sense, there are two fundamental characteristics that all cars have that you have to understand. If you do, as I said, everything else falls into place. The first fundamental characteristic is the energy storage. The second fundamental characteristic is the motor. Let's start with the motor. The motor converts potential energy into kinetic energy. You might think that there are many types of motor out there, and if you look at all the articles about different types of gasoline engines, you might think that's true. But in sense, there are only two types of motors. This has been true since the beginning of human history. So pay attention, because this information that you can use forever. The first motor is the heat engine, and the second one is the electric engine. In the heat engine, burning releases the potential chemical energy in fuel. This heat produces expansion, and this is in turn drives some mostly rotary motion. This is true for steam engines, steering engines, diesel engines, and gasoline engines. The picture shows how four-stroke engine works. This is basically the modern gasoline engine, and it was invented 150 years ago. On the first stroke, gasoline is injected into the chamber by operating a valve that is then closed again. On the second stroke, the cylinder moves upward and the gasoline is compressed. On the third stroke, the energy in the fuel is harvested by igniting it. The resulting explosion drives the cylinder down, and that produces a rotary motion. This is comparable to a bicycle, basically, where pushing down the pedal moves the bicycle forwards. On the fourth and final stroke, the energy burned is emitted. The entire engine requires hundreds of precisely crafted moving parts. That makes the engine heavy and expensive. And since all the heat and explosions cause a lot of wear and tear, you need a lot of maintenance, and even then it wears down pretty quickly. The heat engine also wasted a lot of energy. In theory, we could improve the efficiency to about 50%, but that would mean a couple of things. Firstly, the engine would become more expensive. Secondly, it would have to run at the most constant number of explosions per minute, which is very hard to do in a real world. Finally, the motor should be run at almost maximum power. In practice, even though we've been improving the internal combustion engine for more than 150 years now, a regular car wasted more than 75% of energy it consumes as heat. And sports car like Bugatti Veyron wastes more than 95% of energy if you drive it in regular city traffic. For heat and climate change, the biggest problem is the exhaust fumes. These fumes are unhealthy, but the biggest problem is that burning 1 liter of gasoline produces 2.3 kilograms of carbon dioxide gas. Now, let's look at the electric engine. It all works completely different. We will dive into all types of electric engines later, but fundamentally, they all work by using magnet fields. You might still remember from school that magnetics have poles. We see they have North Pole and South Pole, just like Earth. If you put two magnets together, you will see that the opposites attract. If we take a coil of wire and make electricity flow through it, it creates its own magnetic field. It has become magnetic. If we place this magnetic coil between two magnets, one side of the coil will be pushed up and the other side will be pushed down. This means the coil turns until it is vertical. At At that moment, we quickly change the polarity. That way you can create a rotary motion, and what you are seeing here is simplified direct current motor in action. The advantages of electric motor are numerous. It only has one moving part. We call that the rotor. Therefore, it can be relatively light, compact, and inexpensive. And since magnetic fields are very gentle, an electric motor can last essentially forever without any maintenance. Energy efficiency, that's very important, can be close to 100%. And you can even win back energy when braking. So theoretically, it takes you over 100% if you compare it to the gasoline engine that is only 25% efficient. Because of this, the average electric car is 4 times more efficient than the average conventional car. And if you compare sports car to electric car, is up to 20 times more efficient. So oversizing the electric engine doesn't materially reduce efficiency, and the engines are cheap and light. That's one reason why in practice electric vehicles can accelerate much faster. For health and climate, the biggest advantage is clear. It can run on renewable energy, and the motor itself has zero emissions. This sheet sums it all up, and it's clear that electric motor is superior in every way. So why did we end up with gasoline engine? The answer to that question is energy storage. When you look at motors, the electric engine has the upper hand. But if you look at energy storage, the heat engine has the upper hand. Fuel is a really marvelous way to store energy. Batteries compare very poorly to that. A lead acid battery from 1900 stored only around 0.01 kilowatt-hour per kilogram. That's more than 1,000 times less than gasoline. No wonder the gasoline engine won. A lead acid battery at the end of the last millennium was better at 0.035 kilowatt-hour per kilogram, but that's still about 350 times worse. A nickel metal hydrate available at the turn of the new millennium stores 0.08 kilowatt-hour. This is still 150 times less. But then people woke up primarily because they needed lighter batteries for cell phones and laptops. And now a lithium battery has produced by Tesla Gigafactory has about 0.25 kilowatt-hour per kilogram, still 50 times worse. In the near future, we can expect batteries that stores double that, still 30 times worse. Theoretically, lithium-air batteries can even hold more energy than gasoline, but that is very theoretical. So if we take the efficiency of the motor into account, we could have theoretical situation where actually the batteries are lighter. However, that is only a very long-term perspective. So to wrap up, there are essentially only 2 motors for cars. Heat engines to propel the car forward by burning fuel, electric engines that uses much more gentle and efficient magnetic fields. Electric engines are superior in almost every way. They are lighter, smaller, cheaper, require no maintenance, are 4 times more efficient, cause no exhaust, and can run on renewable electricity. The problem was the battery used to be incredibly heavy, but due to incredible developments in battery technology in the first years of this millennium, the weight of the battery plus drivetrain will soon be less for an electric vehicle. Taking fuel savings and efficiency into account, that means the electric vehicles will be much cheaper to own. So if you look at the fundamentals, the adoption of the electric vehicle is not a question of if, it is only a question of how fast.